In this video, I'm going to be taking a look at the halogens. Now, I have a table here of 4 of the halogens. I've left out astatine. And these halogens exist as diatomic molecules, as you can see from the formulas I've got here. Now, I have got fluorine, chlorine, bromine, and iodine in this list. And fluorine is pale yellow in color. And it's at room temperature and pressure, it's a gas. Chlorine is green, so it's slightly similar in color to fluorine, and it's also a gas. And bromine, on the other hand, is reddish brown in color, and it's a liquid at room temperature and pressure. And iodine is gray in color, and it's a solid at room temperature and pressure. And I've got a couple of pictures here of some of these halogens. I don't have fluorine. Fluorine is an extremely dangerous gas, so I found it quite a task to find like pictures of fluorine. I couldn't find any. But anyway, so I've got chlorine here in this round flask, and as you can see, it's a greenish yellowish sort of gas, and it's gaseous. It's a gas at room temperature and pressure. And we've got bromine. I've got bromine here, and this is a liquid, as you can see. And then we have iodine, and this sort of looks like it's kind of metallic in the way it's shiny and stuff. And iodine is a solid, as you can see, at room temperature and pressure, and it's sort of grayish in color. Now, one of the things I want to talk about in this video, apart from all these different aspects of it, is the reason behind the fact that it's gas. We've got gases and liquids and solids. I mean, they're all group 7. How come they change state? So I'm going to be talking about the reason behind that in this video. So if we actually take a look at the periodic table and we look at these 4 elements here, one of the things you might notice is the fact that the atomic number, the proton number, increases as we go down the period. It goes 9, 17, 35, 53. Now, because of this increase in atomic number, or the number of protons, consequently, the number of electrons also are increasing, and they're going to be equal to the number of protons. So you can imagine iodine has 53 electrons, whereas fluorine has only 9. So if you were to compare the van der Waals forces caused in a molecule of, which occur in a molecule of iodine to the van der Waals forces which occur in a molecule of fluorine, you're going to have wildly different strengths of van der Waals forces, because iodine is going to be much stronger in terms of van der Waals forces than fluorine. Not only because there's more electrons to exert forces when those van der Waals forces are occurring, but the size of iodine is bigger, and so there's much more of a surface area over which the van der Waals forces can act. Now, as you go down the period, this goes like sort of gradually increasing. So fluorine, chlorine, bromine, iodine, and chlorine is sort of along the same lines as fluorine in terms of the number of electrons. So it's also a gas. But then there's a huge jump, and it practically doubles here. It practically doubles from chlorine to bromine. It more than doubles. From fluorine to chlorine, it less than doubles, but from bromine to iodine, from chlorine to bromine, it more than doubles. And so yeah, so this is why this is why iodine is solid, bromine is liquid, and chlorine and fluorine are gaseous, because of the increasing van der Waals forces as you go down a period. Well, not down a period, as you go down a group. Now, the tendency for something to evaporate is often referred to as volatility. Volatility. You know, you probably remember this term, like maybe from GCSE chemistry. Volatility means that something has a tendency to evaporate, and so in this case, since fluorine has the most tendency to evaporate, followed by chlorine, followed by bromine, and then followed by iodine, we can say that as we go down the group, volatility decreases. The tendency to evaporate decreases. And so yeah, that's all I really wanted to talk about in this video. And in the next video, I'm going to be talking about different trends in reactivity when we're looking at the halogens. And so I hope you guys found this video helpful, and I'll see you in the next video.